Hi, in this video we'll look at problems on 2D collisions and look at how momentum is conserved in this program. So we give the solutions. So the first one says a billiard ball moving with velocity v1 3 meters per second in the positive x direction strikes an equal mass ball initially at rest. The balls move off at 45 degrees, m1 above and m2 above and m1 below. What are the speeds of the two balls after the collision? So let's make a sketch of this. Of course, it is already given. So we have a billiard ball. This is the first ball moving at this velocity. I'll be labeling it to u1. This is 3 meters per second in the positive x direction. In the positive x direction. This is positive x direction. Strikes an equal mass ball. So this is the ball it strikes. So it's moving this way at rest. So this is at rest. So u2 is at rest, is stationary, is 0. So of course this will be m1, the mass of the first ball. This will be m2, the mass of the second ball, and this ball is having equal mass. So we can assume, let's assume m1 m2 to be x. So let the mass be x kg, the mass of the balls, each of the masses. So it strikes an equal mass ball at rest. The balls move off at 45 degrees, m2 above. So this is m2. So this m2 moves off. So let's draw this. m2 moves off at this angle 45 degrees. So the balls is not only one ball moves off. So the m1 will still move off 45 degrees and is below. So we have m1. Of course, we can label the final velocity of m2 as v2 and label the final velocity of m1 as v1. So look at this collision. The first mass, this is the first ball, collides with the second ball and they got scattered at the same angle in different directions. This is towards the positive y and this is towards the negative y. So we shall use the idea of momentum conservation in this case. Of course, they scatter at different velocity. So we might end up getting similar velocity for the two of them since they have the same angle. But the concept behind this is the conservation of momentum. Following what we did previously, we know that for conservation of momentum here, you can check the video. We have that this is m1 u1 equals m2 v2 cos theta 2 plus m1 v1 cos theta 1. So this is the conservation of linear momentum along the horizontal. Of course, we didn't. This is momentum before collision, and the whole of this is momentum after collision. Of course, you see that for conservation of momentum before collision should equal momentum after collision. Of course, we only observe the momentum for this first ball because this was stationary, so we didn't have the M2 U2 component, so it didn't appear here. So this is the conservation of linear momentum along the horizontal. So recall again in our last video, for the conservation of linear momentum along the vertical, of course we resolved this yesterday. So we got it as, this is, of course, this is horizontal component of the momentum, and we're talking about vertical, so it doesn't have initial momentum. So this is 0 equals, so when you find the vertical component of this momentum, the upper side and the lower part, so you have it as m2 v2 sine theta 2 minus m1 v1 sine theta 1. So let's label this equation 1 and this what, equation 2. So if you didn't understand how I did this I did this derivation, you can check our previous video. So we shall be using this to solve this problem number 1. So in this question we know that the balls are of the same mass, so m1 equals m2 equals x. The angle for theta 1, this is 45 degrees, so theta 1 equals theta 2, so this is again 45 degrees. So the initial velocity for this first ball is given as 3 meters per second. Okay, the final velocity for this first ball, it wasn't given, and the final velocity for the second ball wasn't given. So we look at the question, what are the speeds of the two balls after collision? So using this formula, we have that, of course, m1 is x and the initial velocity is 3, so have 3 times x equals m2 is still x, v2 we don't know it, this is v2, cos of the angle is 45 degrees, so have plus m1 is x, v1 is yet to be determined, cos 45 degrees. So this implies 3x equals, this is we can factor out this is same as this, so we can factor out s cos 45 degrees. If we factor out x cos 45 degrees, we have v2 plus v1. Let's label this equation 1 because it follows from this. So utilizing this equation 2, we shall be having, this is 0 equals m2 is x, v2 is yet to be determined, sine 45 degrees minus m1 is x, v1 is yet to be determined, then we have sine 45 degrees. So we can write that from this equation 2, if I can call this 2a and call this 2b. So from this 2a, equation 2a, we can have, if this is to cross, we have minus x v2 sine 45 degrees equals minus x v1 sine 45 what degrees. So this can cancel, this can cancel, so we have that v2 equals v1. So it implies that for this problem, the final velocities are the same. And if the final velocities are the same, so what is this velocity now? So if we look at this equation 1, remember this is v1, this is v1, we factor out this. So if you look at this equation 1, we shall be having that, since v2 equals v1, so we can be having that, let's write this again. So you have 3x equals s cos 45 degrees, have v2 plus v1. This is from equation 1. So this is 3x equals s cos 45 degrees. So if v2 equals v1, so we place v1 any place we see v2. So this is v1 plus v1. So this becomes 3x equals, okay, so we have that this is 2v1 cos 45 degrees. So if we make v1 subject of the formula, you now see that this is 3 upon 2 cos 45 degrees. And if you do this maths, you have approximately, this is approximately 2.1 meter per second. So this is the velocity for v1. So what are the speeds of the balls after the collision? So both will have the speed of 2.1 meter per second. So their speeds are the same. So the answer for this is 2.1 meter per second. So if this video interests you, give it a like, share it with your friends, and subscribe for more updates like this. Locate the subscription button below. So the second question says an eagle, this is the mass of the eagle 4.3 kg, moving with speed v1 equals 7.8 meter per second, is on a collision course with a second eagle m2 equals 5.6 kg, moving at v2 10.2 meter per second in a direction at right angles to each other. After they collide, they hold on to each other. The question says in what direction and with what speed are they moving after collision? So you have to solve this and put the answer in the comment section. So you subscribe for more updates. I'll be solving this problem later on in this channel.